I'm going to talk about 1510 Webster, which is a project that I think just recently finished construction in Oakland, California. You can kind of see the bay behind it. It's right there in downtown. It's a 19-story building. And before I move ahead on some of the other details, you can kind of see in this photo a unique mass timber structure that we'll be talking about a little bit more in depth, but it's point supported rather than having kind of like a column and beam system. And that will come into play with how we compared it to a equivalent concrete tower. So as I mentioned, it's a 19-story building, a little over 150,000 square feet. It was the first Type 4A building in the United States utilizing the mass timber, tall mass timber building code and in a high seismic region. It is also the first building in the world with a structure comprised of point-supported mass plywood panels. So as I mentioned, having a kind of two-way point-supported system makes it a little bit more comparable to the like flat plate concrete systems we often see in towers of this size. The top 16 stories of this building are mass timber, and then we have a 2-story concrete podium and 1-story concrete basement underneath this. The reason the project team ended up going this route was partially due to sustainability concerns and reducing embodied carbon, but in large part due to the fact that the mass timber system allowed for a much faster construction schedule and huge cost savings, $30 million in total when compared to the equivalent concrete buildings that they priced. That was equivalent to about a $20 per square foot savings in just structure, going from $70 per square foot to 50. And the main use of this building is to try and make affordable housing for the median income of Oakland, which they felt was severely lacking in the housing market. So by switching to mass timber in this system, not only did we eliminate a decent amount of embodied carbon from the building, but it also allowed them to get that affordable housing in this area in downtown Oakland. So when we did the whole building LCA study for this, we were kind of partnering with Woodworks, and we had the system which was constructed, which is the mass timber design that you're looking at now. And then we compared it to the exact same floor plan, elevation, size, height, but as a concrete building with post-tension slabs. So in order to make a lot of this work and realize all of the cost savings, this project did have to go through extensive testing on that mass plywood system, which I will dive into more in a second. But we have mass plywood columns, mass plywood floor panels. There is still concrete core walls and concrete podium, and then mat foundations in the basement and at level 1. So there's kind of a transfer level here at level 2, where we switch from that mass timber system to concrete below. So one of the challenges when we were doing this to make sure everything was costing out and also, as sustainable as possible, was there was a lot of upfront structural testing, since this was kind of a new system, and getting this to be as efficient as possible. So we worked with Freres, who supplied the mass plywood panel technology and products, and we were able to reduce the column grids, or I should say expand the column grids in the mass timber system from a 10 by 10 foot grid to a 12 by 15 foot grid. The reason we were able to accomplish this was we had concerns about the punching shear capacity at those point supports, vibration criteria, and deflection. And through getting extra testing done, we were able to expand that column grid, which saved 47 columns per floor and drove us from a 7-inch or a 7-ply panel to a 5-ply panel. Which obviously had a big embodied carbon savings as well as cost savings. And because this was tall mass timber and we still have a lot of fireproofing concerns, we had several layers of gypsum on the other side of this, and going from 7 inches to 5 inches, and then having that gypsum made the floor assembly thickness almost exactly the same as it would have been with a 7.5 inch concrete floor assembly. So as I said, the fire protection here, we had 3 layers of gypsum and a 1 3/8 inch effective char layer. That gypsum is thick and unfortunately is what we needed to meet those requirements, but you'll see when we dive into the LCA results how that kind of contributed to the embodied carbon of the structure. And then I won't get too much into these connections and things today, but there was definitely some connections and detailing that we worked with the rest of the team that made a lot of this assembly very easy and very quick. So the erection sequencing and stuff, I also won't get into much, but it did allow for a lot of savings on the cladding as well. And in general, just it was a very, very efficient sequencing, which I don't know what the total construction savings on the mass timber versus the concrete was, but I know that it still went up an entire month faster than they even anticipated with the mass timber because of just the general efficiencies of all of this. So project went really, really well, thankfully. So here's a little bit of details on just the general construction types compared from the mass timber version of what it would have been as concrete, type 4A versus type 1A. And again, mass ply panel floors and columns versus post-tension concrete floors and concrete columns. And then in our analysis for the whole building life cycle assessment, we did look at structure and enclosure, and we used one-click LCA, and we looked at cradle to grave. This is that concrete version. Again, it's the same floor area, same height, slightly thicker foundations because of the added weight of those concrete elements, but also further spans between columns because we are using concrete. And we have a little bit more shear wall as well because of the higher loads on that system. This is kind of just a quick section view of what our enclosure looked like. We had light gauge steel, mineral wool, some high pressure laminate panels, but the vertical enclosure on both of these systems analyzed was the same. So we're really focused in on the structural differences between these LCAs. So looking at this from a whole building perspective, including the concrete podium and the basement and everything, the mass timber scenario only really demonstrated a 5% decrease in embodied carbon versus the concrete system. While that number is smaller than we kind of hoped for, it's still a substantial amount of global warming potential. And the structure was 75% of the total impacts for both of those scenarios. Concrete was 34% of the mass timber scenario still. So there's still a large amount of concrete in that overall building analysis, and the mass plywood was only 12% of that overall impact. So you can see on the right in that graph kind of how it was broken down of how the enclosure, the lateral system, the tower, the podium, and the foundations are contributing. So the podium was a little bit more of a factor in that mass timber, and the foundations were less, and the enclosure and lateral are pretty similar. Now, when we look kind of at just if we're comparing the mass timber portion above the podium to the concrete portion above the podium and just kind of looking at how those compared, we had a 16% decrease in embodied carbon from the mass timber versus the all concrete scenario. Looking at the mass timber scenario, 44% of that total embodied carbon was from the concrete shear walls. And then that 3 layers of gypsum board in the fireproofing was 17% of the total emissions of the entire mass timber tower portion. So that definitely represented a significant chunk of those impacts, and something that when we're looking at lesson learns and things we can maybe do better in the future, depending on how code continues to evolve or gypsum board product data continues to evolve, maybe we can reduce some of that. But as you can see, we also have added acoustic mat and gypcrete in those assemblies for the mass timber version, which also had a decent contribution. Um, if we're looking at considering the biogenic carbon benefits of the in-service lifespan of that building, obviously we get a significant storage from using mass timber. Um, that would represent like a 63% reduction versus the all concrete scenario, which, definitely when you're talking about biogenic carbon, there's various ways of which people feel that should be accounted. But if we're talking just the lifetime of the building and the benefits of locking that in during that lifespan, that is a significant amount of global warming potential there. And then we did kind of dive into some end of life studies as well, looking at the benefits of reusing that mass timber. We also looked at some of the assumptions that one-click LCA makes in terms of material transportation and material wastage. There is an assumption in one-click that all wood products, including mass timber, have a 16.7% material wastage. From our experience in talking to the woodworks people and what we've learned on working on over 160 mass timber jobs up to this point, we felt like that number was really high. Mass timber is often prefabricated and brought to the site, and there's very, very little wastage there. So while we left those assumptions for the initial analysis, when diving in a little bit deeper and adjusting that, as well as decreasing the concrete transportation distance, which was assumed by one-click to be 130 miles to 15, since we knew where the supplier was and we knew that transportation distance was a lot shorter. We were able to reduce the end of life and include some of those stage D impacts. And that had an effect of making it another 17% lower versus the all concrete scenario. But again, we adjusted some of those concrete values as well, so you can see a reduction in the all concrete scenario impacts as well. So that's kind of those added considerations that we took into effect on this and dug a little bit deeper.